Welcome to the Basic Mathematics. The area. The volumes. The surface area. We learn the following in this video. A dot has no dimension. A line has one dimension. A closed figure in a plane has two dimensions. A body in a space is a three-dimensional object. The measure of one dimension is a length. The area, the measure of the space occupied by a figure, is a two-dimensional measurement involving a length and a breadth. The volume, the measure of the space occupied by a body, is a three-dimensional measurement involving a length, a breadth, and a height. A dot or a point is the most fundamental object in the geometry. A point is defined by its location and it represents a position in a space. A dot has a zero size, that is a zero length, zero width, and zero height. In practice, it is marked by tip of a pen or pencil to begin to draw a shape or a figure. A line is a collection of infinite points that extends on both the sides indefinitely in a plane. A straight line could be horizontal, vertical, or maybe tilted, and a line could be curved, with or without any regularity. Lines and segment. A line is an indefinite. A part of line is a line segment with a definite start point and definite end point. From point A to B is a line segment, is shown above. A line segment has one dimension. That is its length. The length is measured of the distance between the endpoints of the line segment. If the line is not the straight line, the length is a distance measured along its path. Parallel lines and segment. Parallel lines are the lines that are at same distance from each other and never meet. The concept of the area. A closed-shaped figure. On a piece of paper, draw a figure with the help of a line or combination of lines, starting from a point and ending at the same point. Note here, it is a closed-shaped figure that covers a certain space, known as its area. The area of the closed-shaped figure is the amount of space it covers in a plane. It can be measured with help of its two dimensions, that is, its length and its breadth. Note: sometimes it is important to know the perimeter, which is the total length of the complete boundary lines that encloses the figure. Unit area. The length and breadth are measured in inches or in centimeters. The area is measured in square inches or square centimeters. To understand, draw a square of unit length. The space covered by this square is an unit area. If the side of the square is 1 inch, the area of this square is 1 inch squared. Please note, the measurement of length and breadth are to be made in same unit of length. Both the measurement of length and breadth are to be either in inches or in centimeter. If the side of a square is 1 centimeter, the area of the square is 1 centimeter squared. What is the area of a square of a side of 2 inches? To get the area of this square, we fit in unit area square in it. A total of 4 unit squares fit in this square. Therefore, the area of a square equals side times side equals side squared. is equal to 2 times 2 equals 4 inch squared. Area of the rectangle. What is the area of a rectangle of sides of 3 and 2 inches? Note a total of 6 unit squares fit in this rectangle. Therefore the area of a rectangle equals length times width. Area equals 3 times 2 equals 6 inch squared. The area of a closed-shaped figure. Simple way to know. The area of the complicated figure is to fill the area with unit squares and count them. It has 65 full squares and 16 incomplete squares. Approximate area is 73 centimeters squared. If we presume average area of half cm squared for incomplete squares. For more accuracy, we can count small squares in the incomplete squares. For accurate calculations of the area of some simple and regular figure, we can work out the formula in terms of its length and breadth, as we could found in the case of the rectangle. It is easier to work out a formula of the area of a closed-shaped figure if it is made out of straight lines only. To make a closed figure with straight line, we need at least 3 numbers of non-parallel straight lines. We will explore more such simple figures made of straight lines, starting from a triangle. A triangle is a closed-shaped figure in a plane with 3 angles, 3 sides, and 3 vertices. Three vertices are A, B, C. Sides are AB, AC, BC. Angles are angle A or angle CAB, angle B or angles ABC, angle C or angles ACB. There are infinite shapes of the triangles. It is desirable to understand the different types of triangle. The triangle can be described by one of the four parameters. Number 1. Position of all three vertices. Number 2. Lengths of all three sides. Number 3. Lengths of two sides and value of one of its angles. Number 4. Length of one side and values of two angles. Triangles can be classified by sides of the triangle. When all three sides are equal in a triangle, AB equals BC equals AC equals A, it is called equilateral triangle. In an equilateral triangle, all angles are also equal. Angle A equals angle B equals angle C equals 60 degrees. When two sides are equal in a triangle, AB equals AC but not equals BC, it is called isosceles triangle. Also, angles opposite to equal sides are equal. Angle ABC equals angle ACB. When none of the sides in a triangle is equal, it is called scalene triangle. Accordingly, its angles are also not equal. It is important to note that the sum of all three angles in a triangle is equals to 180 degrees. Angle B plus angle C plus angle A equals 180 degrees. Perimeter of the triangle is the length of sum of all sides length. P equals A plus B plus C. Classified triangles by angles. When all angles in a triangle are less than 90 degrees, it is called acute angle triangle. Angle B, angle C, and angle A are less than 90 degrees. Classified triangles by angles. When one angle in a triangle is more than 90 degrees, it is called obtuse angle triangle. When one angles in a triangle equals 90 degrees, it is a right angle triangle. Angle C equals 90 degrees. Angle B plus angle A equals 90 degrees. Note: right angle triangle follows the Pythagoras theorem. That is, square of the hypotenuse is equal to sum of the squares of other two sides. C squared equals A squared plus B squared. The area of a triangle. The area of a triangle. The area of a triangle equals 1/2 times base times height. The area of a triangle. Remember, the area of a triangle equals 1/2 times base times height. Note: any of three sides of a triangle may be taken as a base. Then the height would be the perpendicular distance from the base to the opposite vertex. To verify the formula, construct a rectangle on the base of the triangle. Of the width equals to the height of the triangle. We know that area of the rectangle equals base times height equals B times H. Note the rectangle ABFE is divided in two rectangles by the perpendicular CD. Let the area of the rectangle ADCE is X, and the area of the rectangle DBFC is Y. Therefore the area of the rectangle ABFE equals X plus Y equals B times H. Note: the rectangle ADCE is divided into two halves by its diagonal CA. So the area of the triangle ADC equals 1/2 of X. The area of the triangle ACD equals 1/2 of the area of the rectangle ADCE. Note: the rectangle BDFC is divided into two halves by its diagonal CB. So the area of the triangle DBC equals 1/2 of Y. The area of the triangle DBC equals 1/2 of the area of the rectangle DBFC. Back to our triangle ABC, the area equals 1/2 of X plus 1/2 of Y. Therefore, the area of triangle ABC equals 1/2 of X plus Y. As area of the rectangle, X plus Y equals B times H. The area of the triangle ABC equals 1/2 times B times H equals 1/2 times base times height. This formula, will it work for the an obtuse angle triangle, where perpendicular from vertex fall outside the triangle? We will verify it. Extend the base AB to D. And drop a perpendicular CD. The area of triangle ABC equals the area of triangle ADC minus the area of triangle BCD. Side AB equals B and let extended side BD equals Y. Therefore the area of triangle ADC equals 1/2 times H times B plus Y. The area of triangle ABC equals the area of triangle ADC minus the area of triangle BCD. So the area of triangle ABC equals 1/2 times H times B plus Y minus 1/2 times H times Y. Therefore T equals 1/2 times B times H is true for all triangles. Area of a triangle. Heron's formula. T equals square root S times S minus A times S minus B times S minus C. Note A, B and C are the length of sides of the triangle. And S is semi-perimeter. S equals 1/2 times A plus B plus C. Area of an equilateral triangle. Using Heron's formula, T equals square root S times S minus A times S minus B times S minus C. In this equilateral triangle, all sides are equal to A. The perimeter equals 3 times A. And S equals 1/2 times 3A. Substitute it in the formula A. And we get area of the equilateral triangle equals square root 3 divided by 4 times a squared. Note here, the ADC is a right-angled triangle and we can find the height h using Pythagoras' theorem AC squared equals CD squared plus AD squared, where a squared equals h squared plus 1/2 of A squared. Put the value in the formula. T equals 1/2 times base times height. And we get area of the equilateral triangle equals square root 3 divided by 4 times a squared. Hence both the formulas give same result. To prove the Heron's formula, we may focus on two right-angled triangles created by the perpendicular CD in the triangle ABC. Using Pythagoras' theorem, we can work out the value of h in terms of A, B, and C and substitute in the formula of the area. Watch the steps carefully as we show you the proof of the Heron formula. Hope you understood the steps which show you the proof of the Heron formula. Understanding. Quadrilateral. A quadrilateral is a closed-shaped figure in a plane with four sides for angles and for vertices. For vertices are A, B, C, and D. Sides are AB, AD, BC, and DC. And note, angles are Angle A or angle DAB. Angle B or angle ABC. Angle C or angle BCD. And angle D or angle ADC. The sum of angles A plus B plus C plus D equals 360 degree. In a quadrilateral there is a 5 degrees of freedom. And you can make infinite types of shapes with 4 sides and 4 angles. Some of them are unique in their properties and useful in studies and their applications. A very simple quadrilateral where all 4 sides and all 4 angles are equal. It is a square. All angles are equal, and right angle equals 90 degrees. Both the diagonals are equal, and divide a square into equal parts. A quadrilateral, where both the opposite sides are equal and parallel, and all 4 angles are equal, and right angles. It is a rectangle. All angles are equal, and right angle equals 90 degrees. Both the diagonals are equal. Rhombus. A quadrilateral where all 4 sides are equal but not angles. Next is parallelogram, when a pair of parallel lines intersect another pair of parallel lines at A, B, C and D. A, B, C and D forms a quadrilateral known as parallelogram. Here, opposite sides are equal, and, from properties of parallel lines, opposite angles are equal. Please note, squares, rectangles, and rhombus all are parallelogram. Next is trapezium. It is a quadrilateral where only two of its opposite sides are parallel. Next we learn is kite. It is a quadrilateral where two adjacent sides are equal. The area of a quadrilateral. The area of a quadrilateral. To get the area of any quadrilateral, divide it into two triangles diagonally. An area can be worked out using triangles formulas of the area, which t equals 1/2 times base times height. Area of a square. Area of a square equals square of the side equals AB squared equals a squared. In term of the diagonal D, area of the square, T equals 1/2 times D squared. In a rectangle there are two dimensions, its length A and its breadth B. Area of a rectangle equals length times breadth, or area of a rectangle equals base times height equals A times B. Area of a rhombus T equals base times height equals A times H. Note, in rhombus, the diagonal are perpendicular. Area of a rhombus can also be defined in terms of its diagonals. Area of a rhombus. T equals 1/2 times D1 times D2. The area of the rhombus is the amount of space inside the rhombus. To confirm, rotate the rhombus so that one of the diagonal become horizontal. Draw a rectangle of the length D1 and breadth of 1/2 D2. Note, it covers only the lower half of the rhombus. Now, you can fit upper half of the rhombus by splitting it in two triangles. As area of the rectangle equals 1/2 times D2 times D1. Therefore area of a rhombus T equals 1/2 times D1 times D2. Area of a parallelogram can simply be defined as T equals base times height equals B times H. Area of a trapezium can be worked out as T equals 1/2 times A plus B times H, where H is the height or distance between two parallel lines AB and CD. Also, length of AB equals A and CD equals B. The area of a kite is the amount of space inside the kite. Like in case of the rhombus, the area of a kite can be expressed in terms of its diagonals. T equals 1/2 times D1 times D2. Area of the kite ABCD is sum of the area of the triangles BDA and BDC. Area of the triangle BDA equals 1/2 times D1 times H. And area of the triangle BDC equals 1/2 times D1 times D2 minus H. Area of the kite ABCD equals 1/2 times D1 times H plus 1/2 times D1 times D2 minus H equals 1/2 times D1 times H plus D2 minus H. Therefore, area of a kite T equals 1/2 times D1 times D2. Introducing the circle. The circle. A circle is a closed-shaped round figure in a plane, the points of which are always at same distance away from a fixed central point. Draw many lines of same length from one point in all directions. Now focus on the points at distant end. It is a circle. The center. All the points on the circle are at same distance from a point called the center. The radius, the distance from the center to any point on the boundary of the circle, is called the radius of the circle. The diameter, a line segment with endpoints A and B on the boundary of the circle and passes through the center of the circle, is called The diameter of the circle. It can be seen that the diameter is twice the radius, or in other words, diameter d equals 2 times radius r. The circumference of the circle. Point P to P is circumference. The circumference is the linear distance of the total boundary of the circle. It is same as perimeter of any other closed geometric figure. The length of the circumference depends directly on the diameter of the circle. Circumference C directly proportional to the diameter d. C equals pi times d, where pi is a constant of proportionality. To estimate the length of the circumference, divide the circle into 6 equal parts and draw the diameters and chords. There are 6 chords and central angle is 60 degrees. In each triangle, you have noticed that there are 6 equilateral triangles and the length of each chord equals the radius r. Adding all 6 chord sides shows that the circumference is more than 6 times the radius, or 6 times r, or p greater than 3 times d. Now divide circle in 12 equal sectors. The central angle is now 30 degrees. Chord is now 0.259 times d. Circumference is more than the length of all 12 chords. P greater than 12 times 0.259 times d equals 3.108 times d. Further, it is estimated to P equals 22 divided by 7 times d. The value of pi is now found to be 3.14159. The chord, a line segment whose endpoints lies on the circle circumference, is the chord of the circle. The longest chord of the circle is the diameter of the circle. The secant, an intersecting line at 2 different points of the circle, is known as the secant of a circle. Have you noticed that? The secant is the extension of the chord going outside the circle. The tangent of the circle, a straight line that touches the circle or intersects the circle only at one point of the circumference, is called The tangent of the circle. Note: the tangent of a circle would never enter the inside the circle. The point of tangency. The only point where straight line intersects or touches the circle is called the point of tangency. The point P is a point of tangency. Some properties of the tangent. Number 1. A tangent touches the circle only at one point of the circumference. Number 2. The tangent of a circle never enters the inside the circle. Number 3. The important one is that the diameter of the circle at the point of tangency makes right angle with the tangent. The arc, a part of the circumference, or a segment of the circumference of the circle, is known as the arc. The sector of the circle, a part of the circle made of an arc and two radii, is called sector of the circle. Its one vertex is the center of the circle. The segment of the circle. The segment of the circle is made of the arc and a chord. Larger part is major segment, and smaller part is a minor segment. A central angle of an arc or the chord. A central angle of a chord or an arc in a circle is an angle whose vertex is the center of the circle. The angle ACB is an central angle of the chord AB. Radian. 1 radian is the measure of the central angle, whose arc length is the same as radius of the circle. The central angle of the circumference is 2 radian or 360 degrees. Relating radians to degrees. 2 radian equals 360 degrees. 2 times 3.14159 radian equals 360 degrees. Or 1 radian equals 57.295 degrees. Area of a circle. Let us estimate the area of the circle. To estimate the area of the circle, we divide the circles in many sectors. and arrange half of the sectors. From top, vertex down, and other half sectors. From bottom, vertex up. Draw a rectangle of size pi times r and r. Area of the circle is nearly equal to the area of the rectangle. However, if we take large number of sectors, it will be exactly equal. Therefore the area of the circle equals pi times r equals pi times r squared. The area of the circle of radius r equals pi times r squared. The area of the circle of diameter d equals 1/4 of pi times d squared. The area of the semicircle of radius r equals 1/2 of pi times r squared. The area of the quarter of the circle of the radius r equals 1/4 of pi times r squared. Area of a sector of the circle of radius r and a central angle theta in radians equals theta divided by 2 times r squared. Area of a sector of the circle of radius r and a central angle theta in degrees equals theta divided by 360 degrees times pi times r squared. Area of a segment AB of the circle of radius r and a central angle theta. T equals area of the sector AB minus the area of the triangle AOB. Third dimension and volume. We focus now on third dimensions. We saw a dot has a zero size, it has no dimension. A line has a length, it is one dimension subject. We noticed a square has a length and a breadth. This figure is two dimension. Now if we add a third dimension of height to a length and a breadth, it is a three-dimension body like a cube. A three-dimensional space. Some example of three-dimensional simple geometric objects. Number 1 cube. Number 2 cuboid. Number 3 cylinders. Number 4 sphere and hemisphere. Number 5 prisms. Next is cone. Next is pyramids. Some other examples of three-dimensional objects we see every day in our life, like fruits and flowers and other objects. We study now some of the simple geometrical three-dimensional objects. The cube. In geometry, a cube is a three-dimensional body or object bounded by 6 square faces. It has 12 edges and 8 vertices. In a cube, all edges, which measures its length, breadth, and height, are equal. L equals B equals H. Look how a cube would look as it is unfolded. A cube is made of 6 square faces. Watch now how 6 square faces make a cube. The cuboid. A cuboid is similar three-dimensional body like the cube, but it may have different length, breadth, and height. A cuboid is a three-dimensional object bounded by 6 rectangular faces. It has 12 edges and 8 vertices. The sphere. In geometry, a sphere is a set of points that are all at the same distance r from a given point center in three-dimensional space. The circle is similar. In two-dimension plane, center and radius has same nomenclature as in the circle. A sphere is made of infinite number of circles of same center and radius, oriented in all directions, in a three-dimensional space. The hemisphere. A hemisphere is a half of the sphere in volume. The cylinder. In geometry, a cylinder is a three-dimension object with two parallel circular bases at a distance, joined by a curved surface. Circular base has a radius r. The distance between two parallel surfaces are often considered as its height h. Notice now, how is a cylinder made of two parallel circular bases at a distance h, joined by a curved surface? The prism. In geometry, a prism is a three-dimension object with two parallel bases of same size and shapes at a distance, joined by flat surfaces. A prism is a polyhedron comprising a multi-sided polygon base. Second base is parallel to first one, or it is a translated copy of the first. Corresponding sides of the bases are joined by rectangles. The pyramid. In geometry, a pyramid is a three-dimension object with a base of a square or a polygon, along with triangular shaped faces that meet at one vertex above the base. Polygon base has its length and breadth. The distance between base and vertex is pyramid's height h. Slant height of a pyramid is different than the actual height. It is the height of the triangular face which is visible from outside. The cone. In geometry, a cone is a three-dimension object with a circular base, along with a curved shaped face. that converge at a point. Its vertex, away from the base. Cone's base has a radius r, and the distance between base and vertex is considered as its height h. A cone has a slant height, which is different than its height from the base, same as in case of a pyramid. Please note, its face is how they look when unfolded. Volume, the measurement of the capacity. The amount of space a three-dimensional solid body contains, or filled in, is known as its volume. The amount of space in a three-dimensional solid body is known as its volume. It is a three-dimension in unit or cubic unit. Length of a line is measured in centimeter, meter, or in inch. Area of a square is measured in centimeter squared or in inch squared. Volume of a cube is measured in centimeter cube or in inch cube. The amount of space in a cube is its volume. Volume of a cube equals side times side times side equals side cubed. For example, volume of a cube of a side of 3 inches equals 3 inch times 3 inch times 3 inch equals 27 inch cubed. We try to fit unit volume cubes in this cube of side of 3 inches. Watch how 27 unit cubes fit in here. Volume of a cuboid. The amount of space in a cuboid is its volume. Volume of a cuboid equals length times breadth times height. Volume of a cuboid of sides of 3 by 4 by 5 inches equals length times width times height equals length 4 inches times width 3 inches times height 5 inches is equal to 4 times 3 times 5 equals 60 inch cubed. The volume of a sphere. The volume of a sphere depends on its sole dimension, its radius. As it is a symmetric body, the volume of a sphere, V equals 4 divided by 3 times pi times r cubed. The volume of a cylinder. A cylinder is a three-dimensional object with two circular bases of radius r and a length, or height, h. The amount of space in a cylinder depends on its radius and height. The area of the circular base of the cylinder equals pi times r squared. The volume of the cylinder equals area of the base times height, equals pi times r squared times h. A prism has two parallel base faces of same size and shape, such as triangle, at a distance joined by flat surfaces. The volume of a prism depends on the area of bases and distance between them, its height or length. Therefore, the volume of a prism, V equals area of the base times height. A pyramid has a base of a polygon such as square, along with triangular shaped faces, meeting at one vertex above the base. The volume of a pyramid depends on the area of the base and perpendicular height between the vertex and the base. Therefore, the volume of a pyramid, V equals 1/3 times area of the base times height. The volume of a pyramid, V equals 1/3 times area of the base times height, equals 1/3 times a squared times h. Please note that the volume of a pyramid equals 1/3 times volume of a cuboid of same base and height h, equals 1/3 times L times B times h. A cone has a circular base of a radius r, with curved shaped face that converges at a vertex above the base. The volume of a cone depends on the area of the base and perpendicular height between the vertex and the base. Therefore, the volume of a cone equals 1/3 times area of the base times height, equals 1/3 times pi times r squared times h. The volume of a cone equals 1/3 times area of the base times height, equals 1/3 times pi times r squared times h. Always remember, The volume of a cone is 1/3 of a cylinder of same base and height. V equals 1/3 times volume of a cylinder. E equals 1/3 times pi times r squared times h. Volume of the liquid. Unlike solid object, the liquid are fluid and take the shape of the container where it is kept. To measure the volume, the liquid is put in cubical or cylindrical jar of known dimensions. To measure the volume of small quantity liquid, it is generally put in a pre-calibrated measuring jar. Volume by displacement methods. The volume of a solid can be found by immersing it in a container of water. The volume of the solid is equal to the volume of the water it displaces. Here, an apple displaces 3 centimeters of water. Volume of displaced water 10 times 10 times 3 is equal to 300 cubic centimeters. Equals volume of the apple. Surface area. The surface area of a body is like the area of its skin. For example, area of the skin of an apple. Area of the surface which cover the body. Example of peel of a banana. The cube. Watch how a cube is bounded by 6 square faces. Surface area of a cube. The volume of a solid is covered with a surface. The measurement of the area of the surface of the body is also very important. Surface area of a cube is very simple, as it is covered by 6 equal squares of a side equal to the side of the cube. Surface area of a cube equals 6 times a squared. Surface area of a cuboid. A cuboid has a length, breadth, and height. Like cube, it has also 6 faces. Depending on the length, breadth, and height, Faces are three types of rectangles in shape. Surface area of a rectangle equals 2 times length times height, plus 2 times length times width, plus 2 times width times height. A cuboid of length of 4 cm, breadth of 3 cm, and of height of 5 cm. Find its volume and surface area. The volume of the cuboid of length of 4 cm, breadth of 3 cm, and of height of 5 cm is equal to 3 times 4 times 5 equals 60 cm cubed. The surface area of the cuboid equals 2 times 4 times 5 plus 2 times 4 times 3 plus 2 by 3 by 5 equals 40 plus 24 plus 30 equals 94 centimeters squared. Surface area of a sphere. A sphere is made of infinite number of circles of same center and radius oriented in all directions in a 3D space. Surface area of our outer surface of the sphere of radius r equals 4 times pi times r squared. Surface area of a hemisphere. Surface area of a hemisphere of radius r is equals to the surface area of the half sphere plus area of the flat cross section. Surface area of a hemisphere equals 2 times pi times r squared r2 plus pi times r squared equals 3 times pi times r squared. Surface area of the cylinder. A cylinder has 2 parallel circular bases and 1 curved surface. Surface area of the cylinder equals area of 2 circular base of radius r plus the area of the curved surface of height h. Surface area of the cylinder equals 2 times pi times r squared plus 2 times pi times r times h equals 2 times pi times r times r plus h. Surface area of a prism. A prism has 2 parallel bases of same size and flat surfaces joining them. Surface area of a prism equals area of 2 parallel bases plus area of all flat surfaces joining them. If the base is triangle of side A, B and C, the area of the triangle can be calculated by Heron's formula. Surface area of the sides equals A times H plus B times H plus C times H equals H times A plus B plus C equals H times perimeter of the triangle. Surface area of the prism equals 2 times area of the base plus H times perimeter of the base. Surface area of a pyramid. A pyramid has a base and triangular faces. So the surface area of the pyramid equals area of the base plus area of all triangular faces. If a pyramid is made on a square base of side A and slant height is S, the surface area of the pyramid equals a square plus 4 by 1/2 A times S equals a square plus 1/2 times S times perimeter of base. Surface area of a cone. A cone has a circular base and curved shaped faces. Surface area of a cone equals area of base of a radius r, an area of the curved surface of slant height S. Surface area of a cone equals area of base of a radius r and area of the curved surface of slant height S. Surface area of a cone equals pi times r squared plus 1/2 times 2 times pi times r times S equals pi times r times r plus S. Thank you for watching video on surface area and volumes. Please subscribe this channel and watch all our video already on the school mathematic.